Can you still record all that? Okay. No response. I'm not getting any response. I want to be sure you are able to get all that. Okay. No response to you. Okay. So, in that sense, I want to show you something from my system here. Okay. Give me a moment while I reach out to it. Okay. So I want to pick some questions out. And then I have okay. So I'm going to project this. I want to pick the particular question here. That we can treat all of this together. Okay. So let me just do it this way. So I'm bringing this down and I'm taking my screen instead. Okay. So here, let's work with this. These are JAMB questions, past question and answer that we can work with. And I'm just going to go to chapter 2 where we have binary operations. Okay. These ones are normal fraction, decimals, and all of that. Okay. These are solutions for this. I'm interested in chapter 2. So that we can consider good. This is indices and sorts. We have done all of these already. Okay, this is the solution for it. Okay, these are number bases. We've done these two. So we are also making progress. I can see that we are making progress. It's just that we are not fast enough. Set theory, we've mentioned it. There are past question and answers in JAMB that we can lay our hands upon, and solutions for the set theory. Okay, so here we have binary operations, and I'm just going to make the screen big enough. Okay, so we have binary operations here. Can make it so big. This is from 1978, but I can quickly go to the latest set of questions, at least anything 2001. Good. So here, this is a question from 2001. Identify the elements with respect to multiplication, the identity element, actually. Which one is the identity element with respect to multiplication? I remember when I was teaching identity, I told you that identity element is the element that when you operate on it, it will return the element you are operating on it back to you. I mentioned the case of identity element under multiplication. Anything you multiply by 1 will return that number back to you. So if I multiply minus 20 by 1, I will get minus 20 back. If I multiply 200 by 1, I will get 200 back. All right. The only number that I will multiply by 1 that will not give me my number back is 0. Is 0. So 0 does not fit to be multiplied under identity. So when I need to talk about the identity under multiplication, 0 is not going to be an element I'm going to consider. because 0 times 1 will return 0 to me. All right. So 0 is not an element to be considered. But any other number you multiply by 1 will give you that number back. So that's the same method we're going to use this. When you say k times k, it gives you L back. So it's not giving you the k. K operated on L give you M. But k operated on M gives you k back. You keep that. L operated on M gives you L back. Keep it. It's telling you something. M multiply on M gives you M back. The binary operation, let me see if this can be annotated. I want to see. I just need highlighter, spotlight. Good. Now, this is the binary operation, and I need you to follow suit very well. This is the binary operation. So when I put k and operate it on another k, what I will get is L. But when I put k and operate it on L, I will get M. When I now put k and operate it on this M, what I get back is my k. So that's telling me something about k and M. When I operate L on this M, I get my L back. And when I operate M on M, I get my M back. So you can see that all of these are reflecting back all of this, which means this particular element is my identity element. So I will just go into my options and pick where I can find this. And that is option C. That is option C. Option C is there. Then JAMB 2001. JAMB 2001. Please, if you don't understand, let me know. I can explain to you. Any question before I move on the issue of this identity? Okay, so none. You can see that this is JAMB 2001. Another question on binary operation in the same year, 2001. 2 questions. So we can't joke with this topic. We cannot joke. If out of 50 mathematics questions, we're already seeing 2 under one topic, that's massive. That's saying something that we need to pay attention to it. Now, for this 2001, it's saying our operation star is defined on the set of real number by A star B is equal to all of this. If the identity element is -1, find the inverse of element 2 under star. So I'm just going to do the working on the screen. I'm going to do the working on the screen. Okay. So I'm going to work with this formula. A star B is equal to A plus B plus 1. So the condition for identity element is that A star, anything called identity element, must give you A back as your answer. It must return A as your answer. So, and they told us that our identity element is -1. So all I will need to just do is, if my identity element is -1 and I need inverse, then there is another possibility that A multiplied by the inverse of A must always result in identity element. So this is the rule that I'm going to use to get the value of my inverse. Then I'm going to now continue and say A star A inverse. So I'm going to use, instead of using A star B, I'll replace B with A inverse because I need to get A inverse. So it means A star A inverse will be equal to A plus A inverse plus 1. But by the time you do all of this, the answer you must get says you will get -1 because -1 is your identity element. So I'm going to say A plus A inverse plus 1 is equal to -1. I need to get A inverse. I need to get A inverse. So what I will now do is to say, sorry, this is supposed to be star actually, A star A inverse. Okay, so that's A plus A inverse minus 1 according to this rule. So what I will now have is minus 1, or let me just write it like A plus A inverse, then is equal to minus 1 plus, this will be minus 1 minus 1, that is minus 1, because when you transfer this to the other side, it will give you minus. So you now have A plus A inverse is equal to minus 2. And they've given us the element, inverse of the element 2 is what we are looking for. So instead of writing A, we replace element with 2. So it will now be 2 plus A inverse is equal to minus 2. So this one will also go to the other side. That means our A inverse is equal to minus 2. Now, it's 2 that is here. By the time it's crossed to the other side, it becomes minus 2. So your A inverse is equal to minus 4. So this is our answer. And that is the answer here, is A. The answer there is A. That's the solution to that. JAMB 2001. That's the solution. If I take this right up away, everything will disappear. So if you need to write, you can quickly note it down or screenshot your, you can do a screenshot to keep that so that I can move on.
Excuse me, sir.
Okay, so I'll move to the next one.
Please wait.
I should wait? Oh, yeah.
Yeah, so I wanted to say that you get this minus 2 by times plusing the 1. You know, you use a minus 1, which is if you are to change
Yes,
it.
minus 2. Yes, minus 1 will give you minus 2. So what you have left is A plus A inverse here.
Okay.
But if you check the question, look at this place. They said we should find inverse of element 2. So if A is an element, inverse of A is A inverse. So they've given us an element A as 2. So instead of writing this A, we replace it with 2 here.
Okay, sir.
That's what happened. So inverse of 2 is minus 4.
Okay.
Can I move on?
Yes, sir.
Okay, so I'm going to take this away, and then we'll go to the next question. Because if we are just teaching the topics and you are not solving questions, it may look a bit difficult for you to understand. So let's solve this question in 2002. This question in 2002 says the binary operation is defined on the set of integers like this. P and Q by P star Q is equal to PQ plus P plus Q. This one is simple. They want us to find that, they want us to find 2 star 3 star 4. So you need to be careful with it. The way I'm going to solve this, just a bit, I want to raise it up a bit so that I can have space to work. Okay, so this is it. I will do 2 star 3 star 4 will give me, I will do it one by one. In the real sense, when you are solving mathematics, board math, so you have to do what is in the bracket first. You have to it's touched. Then we now expand 3 star 4 in the order that they expanded P star Q in the question here. The way they have expanded this here is the way we are going to expand what is here in the bracket. So your 3 will be P, your 4 will be Q. So that will be 3 times 4 plus 3 plus 4. That's what we will do. So I will just compress that solution. 3 times 4 is 12. 12 plus 3, 15. 15 plus 4, that's 19. So my answer will now be 2 star 19. This is what I will have, 2 star 19. Now that I have it in 2 formats, I will still go back. The way it is expanded in the red box is the way I will now do this. So my 2 will now be P, my 19 will now be Q. So I will still go again. I will say 2 times 19, then plus 2 plus 19. So this will be 2 times 19 is 38 plus 21. And that gives you what? 59. That's your answer, which is option C here. Which is option C there. All right. So we have as many questions as possible that we can work on. We can see 2002, another question. It's more or less like maybe in the early 2000s. You can only see 2 questions or as a certain, because this is the way I teach students. I will go through years of questions and then I will see which question is being repeated, because there is likelihood of the question being repeated. When you see the trend in 2001, 2 binary operation, in 2002, 2 binary operation. So if you work on binary operation very well, that means there are 2 questions that will be waiting for you as a bonus to work on under mathematics. Go to another one, check how many questions is coming out under this topic. So by the time you check about 15 to 20 topics and you see 2 questions, that's 40 out of 50 questions already, guaranteed that once you see, you'll be able to solve. So don't run away from past questions and don't run away from practicing questions, because the one that came out in 2002 is quite different from the one that will come out in 2001. They are different. It's under the same topic, but the way the question is structured are different. So I need you to work on that. All right. I want to quickly check. Do we still have, okay, I think we have some minutes. So as much as possible, we should be able to do that. Can I move to the next question? Or maybe I should skip to some more recent question. Let me see if I have some more recent question. I have 2007, 2008, 2012 is here. Okay, even in 2012, we have 2 questions. 2013, 1, 2014. Okay, let's check this other side. There are some questions here. 2017, I think the last updated version of this. So let me just solve this question in 2017. Or let me see. Is there anyone that wants to try any of the questions? Probably 2009. There were 2 questions that came out in 2009. You can screenshot you can make a screenshot of your phone or laptop. There are 3 questions showing vividly here. Let me project it up. Yeah, you should be able to snap for all the 4. Yeah, these are 4 questions at a go. 1, 2, 3. Okay, 4. It's showing 4 questions at a go now. So you can screenshot these questions. 2 in 2000. In fact, 3 questions. Imagine 3 simple questions in 2009 only. 3 different questions. So you should know that binary operation is a regular topic that will come out. 3 different questions in 2009. Wow. Just quickly write down. If you are writing, I'll give you time. I want you to work on them and supply the answers that you got. I will cross-check and confirm the answer. So make a screenshot on your phone or write it down quickly. Is there anyone that can solve any of the questions for me? Let me know. I think I can see the one that looks like the one we just solved now. Probably anyone wants to try. Let me see. That question 29. Lizzie, Can you try something on that question 29?
Yeah, I will, but I think I will send it to the group. Sorry.
No problem. No problem. All right
Thank you.
then. So these are the 4 questions. I want you to try and snap them or quickly write them down. If you are done, let me know so that I can quickly move on because of time.
I screenshot it.
Oh, fine. That's a better and faster way to get it done. So I'm going to solve this as the last question for the day, and then we'll move to another topic without wasting time. So here, we have this question that says, this is the operation on set of real number. And they ask us to find 3 star minus 1. So anywhere you see xy, you treat x 3 star minus 1. Anywhere you see x, you put 3. Anywhere you see y, you put minus 1. Note that the order is very important, order of arrangement. Don't go and put minus 1 where x is. X is coming first. X is the first letter that appear. Y is the next letter that appear. So the way they arrange it is that 3x is coming first, 2y is coming next. Don't go and put 3y and 2x, it will be wrong. So these are the things you need to know. So if I want to do that 3 star minus 1, this will now be, and don't confuse the number with the letter. We are not concerned with the letter and with the number. We are only concerned with the number, letter. So anywhere I see y, what I'll put is 3. So 3 is staying on its own before. I was supposed to put x, but I've been told that x is 3, so I'll put 3 instead of x, plus 2. Y is next, but my y is minus 1, so I'll put minus 1 there, then minus 1. This arrangement used to confuse students. So if you are able to see that your x is 3, your y is minus 1, you are safe. You can see that this last minus 1 does not affect the value of my y, and it should not affect it in any case. So from that, 3 times 3 will give me 9. Plus times minus is minus. So you have minus 2, then you have minus 1. So what do you have at the end of the day? 9 minus 3 is 6. It's a very simple question. You cannot spend up to 15 seconds solving this question if you have done the arrangement properly. 6 is option C. And as many mistakes you are making, you are likely to see your answer there. That's one thing you need to be very careful about. Some of you make a mistake, you are likely to see your answer there. It's possible. Your answer might be there. So I think this is a very interesting one. Okay. So on this note, I want to believe that we can handle binary operation. I want to believe that we can handle binary operation. Can I take this away? I want to move on. Okay, like let me give 10 more seconds, then I'll move it away. All right, so I'm moving this away. So we have that. Now, let's go to another topic. These are solutions for the questions we have there. These are the solutions. Let's talk about inequalities. Let's talk about inequalities. Inequalities is of 2 types. We have singular inequality in one variable. So I want to talk about inequalities. Maybe I should just pull down the screen share on this and go to my whiteboard. So I'm leaving inequality. I'm leaving binary operation, sorry. So I'm going to inequalities. Inequalities are another interesting topic. Inequalities. Okay. Inequalities. Inequality we'll deal with the inequality in one variable. All right, we'll start from there. Please note these signs. This is less than. Some people will say, we know now. It used to scatter at some point to this is greater than. Greater than. And this is less than or equal to. This is greater than or equal to. This is not less than. This is not greater than. So this is not less than. This is not greater than. All right. I think these are the things you need to know. Now, of course, I can show arrow on a number line. If this is 0, -1, -2, anytime something is going like this, less than, the head of arrow is less than. -1 is less than 0, -2 is less, -3. So any of the number here, -3, blah, 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 they are all less numbers. So when your line is facing this way, according to the direction of the arrow, that's less than. This is 1, this is 2, this is 3, and it continues. When your arrow is facing this way, this is greater than. All right? And then so we can combine a lot of things that you need to know. So you know less than, you know greater than. Most times the arrow used to have what I call a base with a 0. Now, when you have something like this, and I'm going to show you that in the next slide, please note that once it is 40 minutes, the class will end. I think we have about 7 to 8 minutes left. So I just want to establish the basic analysis of inequality. So next class, we are going to go into it fully. I was hoping we started around 6:10. So it's all right. Let's see how it goes. So let's talk about this. If you have 5 is less than x, then you can project. X can be any number. That means you have to start from 5 with a base, and then you increase. There are a lot of numbers that are greater than 5. 5 is less than 6, x can be 6, x can be 7, x can be 8, x can be 9, x can be 1 million. So you write like this. This is the symbol that represents 5 is less than x. If I want to write -5, let me change this color. Minus, how am I even painting when I can just, -5 is less than or equal to x. Now, this one is a different one. So, of course, I'm going to start from -5. It is less than or equal to, so x can be -4, x can be 0, -5 is less than 0. But when they say less than or equal to, then what it means that you have to shade this base. You have to shade it. Then there is a way you can also write it. This 5 is less than x. I can do it like this: 5, x. Please note my bracket. I need you to note my bracket. 5, x. That is 5 is less than x. But in this case, I will write it like this: 5, x. The curly sign means that it is opened, but the braced sign here means that it is closed. All right? It is closed. The same thing with greater than. I can write 7 is greater than y. And there's nothing to worry about. 7 is greater than y. So I'll start from, it's more or less like saying y is less than 7. You can interpret this one as y is less than 7. So you write your 7 here, you do like this, and on the how you want. But if I write y is less than, y is less than or equal to 7, Then what I'm saying is that my 7 starts here. I have this. I will shade. Anytime you see less than or equal to, it has to be shaded. So any number less than will follow the other way. Less than will follow the left. Just like you are raising your hand. When you raise your hand in a V form, so you can see that on your right hand, you have greater than. So greater than will face, the arrow is facing your right side. That's greater than. If you raise your left hand too, the arrow is facing the left. So that's less than. Just like you raise your hand in form of arrow like this or like this. And that's how you see when you raise your 2 hands in that format, you have less than and greater than. All right. So note that. Now, is it possible we have the 2? The answer is yes. You can have something like 5. I can use any number. Minus 13 is less than x and x is less than 7. So you can have something like that. X is a number between minus 13 and 7. So I'll create 2 numbers, minus 13, 7. Then I'll do this. And then I'll do this. Then I'll have a line. X can be a number between these two. So I'll put x in between. This is minus 13 is less than x and x is less. So I can pick all the numbers that are in between. I can pick all the numbers. What are the numbers? I can be minus 12. S can be any. It can be minus 11. You can continue like that until you get to 6 because 6 is a number less than 7. So you can see all these numbers. They can ask you how many numbers are in this set. There's a way they can link inequality to set theory. I mean, it's a very wonderful thing to understand maths. All right, very wonderful. They can ask how many numbers are in that. So you need to know all these things. So you can practice some of these. You can practice them very well. It helps. And then if you have a closure, maybe 2 is less than or equal to m, and it's also less than, let's just say 17. Anyhow, these are just assumptions. So I can have this. So this will be 2 here. This will be 17 here. Now, this is less than or equal to, I have to shade. Don't always forget to, you must shade once it is less than or equal to. And then I have 17 here. Then m is in between. So any number from 2, this one is from. When you see less than or equal to, it means from or to, depending. But when it is strictly less than or greater than, you say between. So like I mentioned now, between minus 13 and 7 is from minus 12 to 6. That is in between. 13 and 7 are not parts. But in this case, 2 is parts, but 17 is not parts. So I can have something like x is less or equal to m, less or equal to y. X and y are numbers. So I can put my x here, I'll put my y here. Then I'll shade this because it's less or equal to. Then I'll have this extended to y. I'll have to shade too because both sides have less or equal to. Then m is a number in between. So note all these arrangements. Then we'll now begin to solve. Anytime they give you an equation in of this format, you are going to treat it as equal to. Yes. Let me quickly confirm something. I want to see. I don't know if our time is fast spent. It's not showing me the remaining time here because I don't really want the class to end abruptly. So I think I will stop here. If you have any question, you are free to ask. And if you want to copy anything, I can quickly show you before the class is ended. Because I want to be very mindful of time. So any question? Can I put down the screen?
Yes, sir.
Okay. All right. So we just have less than 10 seconds, as if I knew. So please go and practice questions and we'll see later. Thank you.